All right. Well, welcome everybody. It's 10 p.m. on the East Coast and 7 p.m. on the West Coast in the US. And if you don't know who the heck I am, my name is Micah Silverman, and I work with Randall Degges, who's going to be presenting tonight. And I just wanted to do a little introduction here. I am a chapter leader for a DevSecCon chapter in Virginia, so all the way on the other side of the country. And this organization is super near and dear to my heart because it brings together developers and operations people and security professionals. And we've been kept apart too long. We're all in the same tribe. And I love that there's an organization that brings us all together because we're all concerned with the same things. So if you're a developer, you are definitely concerned with operations and security. Same thing if you're a security professional, you're definitely concerned with developers and operations and all the way around. So I'm delighted to be here with you tonight. This is a really great talk that Randall has for you tonight. And I would like to bring Randall into the stream here and turn things over to him.
Hello, thanks for the intro, Micah. It's so cool having one of the other DevSecCon chapter leads help kick off the inaugural Bay Area event. It feels very special over here. So thank you.
For sure.
All right. Well, hello, everyone. As Micah said, I'm Randall. It's super nice to meet all of you for our very first Bay Area meetup. So I live in Concord in the East Bay, just in case you're wondering. Please, by the way, feel free to jump into the chat. So we're using StreamYard, so we have comments coming in from like YouTube, and we also have Discord open. So if you aren't a part of the DevSecCon Discord, you should absolutely join us on there right now. As a matter of fact, I will drop the link in the chat right now. One moment. Copy this link. Also, Kyle's here. What's up, Kyle? Welcome, welcome. Okay, so I just shared the Discord link, and we have our own Bay Area chapter channel in the Discord as well. So please join us. Also, I have some pretty exciting news. You know, like I said, this is our first ever meetup, but starting next month, we're going to hopefully have an in-person venue. So I was talking to a buddy of mine that runs a tech company down in the South Bay who was more than willing to open up their offices for us. So that is in progress. We'll have more announcements through the meetup group and stuff like that later on in the Discord, but hopefully we can hang out and have some pizza and beers or something like that in the future. So looking forward to it. Anyways, so what are we talking about today? Well, I thought that for the very first meetup, it'd be sort of fun to, introduce myself to you all a little bit, get to know each other a little, and also do it in sort of a fun way. So instead of talking about, DevSecOps best practices and things like that, I thought it'd be a little bit more interesting to talk about what are all the ways you screw things up in the real world. And so that's what we're going to do. We're actually just going to share a bunch of my personal programming horror stories. And along the way, hopefully learn a little bit of stuff about building better web applications in particular. So let me pull up my slides and we will get into it. All right, so here we go. This talk is titled The 12 Factors of Pain and Suffering. And like I said, it's just a collection of my personal sad programming stories. And feel free to interrupt me if you have any questions as we're going through. Like, again, drop comments in the chat and I will answer them in real time. So a little bit about me. So I run DevRel at a little company called Snyk. It's SNYK. If you haven't heard of us, we're basically a developer security tool. So we make it easy to sort of find and fix security vulnerabilities in the applications you're writing. So I primarily nowadays do a lot of Python, JavaScript, and Golang development. I do a lot of open source work. I do a lot of writing, so blog posts, things like that, publishing technical books on occasion. And then also, I would say the thing that I value the most from my background is that I've just been very fortunate to have been able to build a lot of various things in my career. And that's really the thing that I enjoy the most, is just building things and getting stuff live. It just really gets me excited. And that's part of the reason why I love DevSecOps so much, is because it combines, all the things you need to know, right? Like the development side, the deployment side, the security side. And if you know it really well, you can just build things faster. And I think that's really cool. So that's my personal motivation. So first of all, what is the 12-factor app? because the 12 factors we're talking about today are all based on something called the 12-factor application. And basically, this is something created by one of Heroku's co-founders, Adam Wiggins, who's a personal hero of mine. And it's essentially like a manifesto for building simple, scalable, and dependable web applications. It's been around for a long time. It's fairly well known in the development space. And a lot of these factors, even though some of them are dated, are extremely important to understand when you're building web applications. Because if you don't follow these factors, then you end up in situations like the ones I'm about to describe. And by the way, all these things are taken from my real world personal experience, just so you know. So, as I said before, I screwed up. Now, the first factor in the 12-factor application principles is all about your code base, right? And the idea that, or what the 12-factor application says, is that you should have one code base tracked in version control that is deployed many different times. So what does this mean? Well, you have your code, right? You have your project. You deploy that into different environments. So you deploy it into production, into staging, into development, into multiple development environments potentially, and all of these different things. And so this is the best way to manage your code base according to the 12-factor application principles. So how did I screw something really simple like this up? Well, back maybe 12 years ago or so, I was running a company, and the company I was at was essentially a very popular website that took people's phone numbers. When you Googled it, it was the #1 search result. We showed people a web page, and on the web page, we pulled in information like people's name, the rough approximate area where the person lived, if the person was a spam bot or not. So we basically just provided free information about phone numbers, and people would use us all the time to, Google a missed call number to see who it was, things like that. And this website was amazing because the way we monetized it was through this affiliate program. And what would happen is people would Google a phone number, they would land on our webpage, they would learn a little bit about who the caller was. And then if they really want to get more information about the caller, they could click this link to go to a partner company. The partner company would do like an actual in-depth, person search, something like this. And we would get paid like a pretty big commission. It was about $25 at the time per search. And we had a ridiculous amount of people landing on the site at the time. We were like the #1 site on Google for years. So what happened? Well, one day back in, I think it was like 2012, I believe, Google rolled out the Panda algorithm update. And the Panda algorithm update was a massive search change they released, which completely destroyed websites like this. So websites that had millions and millions of pages indexed with all sorts of information look very spammy to Google. And so Google basically said, hey, I really hate your website, and completely delisted us. Now, when this first happened, I was freaking out because, I was doing all the technology for this. I had a couple partners, so I was running the business with them. And basically, as soon as the website went offline, the money completely stopped. And so that's a really big deal when you're running a company, and overnight it completely, stops being profitable. So what did I do? Well, the first thing I did is I thought to myself, all right, I need to figure out how to troubleshoot this or appeal the decision with Google, but I got no information and I couldn't really find anything. And so I had two choices. One, I could write an article, post it on Hacker News, and hope that someone from Google actually sees it and unbans me. Unlikely. Or two, I could copy the code base, which I did. I literally just, cp-r'd my folder with all my code in it. I purchased a new sketchy domain name. And then I spent the next, 8 hours or so creating new graphics for the new site. And I basically just cloned my existing site and launched it under a brand new, brand identity. I even changed the colors in the webpage and things like that. And my thought process was, we just have to get this online like ASAP. And so maybe Google screwed up on the first code base. And so if I launch a second one, it'll be better in no time, right? So that's what I did. So spent like 8 hours on this, completely sweating the whole time, got the new thing launched, submitted it to Google for indexing. And within, 24 hours or so, I could see that Googlebot was crawling the site, and we started having our pages reappear in Google search. And so this is actually pretty awesome. So things were starting to get back online. I could see traffic picking up again. We were starting to make some sales again. And so, it was motivating. And then about, maybe 4 or 5 days after that, Google shut down the new site as well. And so then what did I do? Well, I decided, okay, again, we're in a situation where time is of the essence. So I don't have a lot of time to experiment with things. I'm just going to copy the code base again. So I copied it again. So I created a couple other additional website clones. I bought 2 new, relatively sketchy domain names, I will admit. And I spent the next 16 hours, so 8 for each, building a new branded version of each of these. And in this iteration, I even started experimenting with things like changing the HTML structure a little bit. I thought maybe there was something weird about that Google was picking up on, tweaking some of the JavaScript libraries I was using, etc. And this worked again, okay, for 48 hours or so. Both of these domain names got listed. We started getting some sales. And then, about a week later, bam, they're both completely delisted. And so at this point, I started freaking out because now I'm maintaining 4 copies of this site, right? I have these 2 clones, this clone, and the original. And by the way, I was maintaining all of them because my thought process was, well, Google made a mistake. They're going to unban me eventually. And so I need to continue doing things like adding features to the sites and all this stuff. But because I was doing that across literally completely different code bases at this point, it was a huge pain in the ass. I was literally going into each one of these things, tweaking stuff. So if I wrote a feature in the original code base, I'd then rip out the relevant functions and stuff and copy and paste it into these code bases. It was like, my own version control nightmare. And when these 2 new sites got banned, I went crazy and I said, okay, I'm just going to spend the next however long I need to copy and pasting this entire thing and going through this process from scratch because we cannot have this business fail. So for the next, 30 to 60 days, this is really all I did. I worked around the clock building and launching these sketchy websites that would almost instantaneously get banned towards the end there. And towards the end of that 60-day period, Google's, algorithm had gotten a little bit better and they were just not indexing the site at all. And so this no longer worked. But for those 60 days, my life was absolutely terrible. And I was constantly playing cat and mouse trying to outsmart the search engine. And it was just a losing battle. So this experience was absolutely brutal. And what I learned from it is that you should listen to the 12-factor app principles, have one code base. If you need to do something terrible like what I did, at the bare minimum, just create a bunch of variables in your code base so that you're still maintaining one code base. Maybe you variabilize like all the HTML colors and the images or whatever you need to do, but please do not do something as stupid as what I did. Have one code base, track it in version control, and deploy it to many different environments. That's the TLDR. All right, so what's the second factor of this 12-factor application principles thingy? Well, it's basically all about dependency management. So the idea is you want to explicitly declare and isolate all of your dependencies. Now, again, super straightforward, right? So here's how this works. You declare dependencies. So let's say you're building a JavaScript application. Well, you basically, build a package.json style file and you include all your dependencies here. You say like, I'm using the Axios library at version 0.18.0, right? Stuff like this. And then you isolate your dependencies, which is basically saying once you've declared them, if you need to reproduce your build, all you need to do is run npm install. It's going to take a look at your dependencies and all of your version requirements. It's going to install everything here. And bam, you should ideally be able to run your code base now, right? Pretty straightforward. Well, the way I screwed this one up is actually a pretty interesting story, I think, because it's still something that I think could be easily screwed up by developers. So this was, again, quite a while ago, but I was working on this fun side project. I was building an image optimization API. And honestly, it was one of the most fun projects I worked on. I thought it was really cool. But basically, here's the idea. So you're a developer, you have an image, you want to publish it on a website and make it super fast, right? So have it use as little bandwidth as possible to transfer the image from the web server to your users. So if you have an image, what you would do is you would send it to my image optimization API. The image optimization API would say, okay, I'm going to optimize the image for you. And then it would, run some optimization tools, shrink the image down without messing up the quality, and then send it back to the developer so they can then, use it. Now, the way I built this thing was, this was a side project. So I had a VPS at the time, and I literally went and found a bunch of image optimization command line tools that you could use to do this. I installed them all on the VPS server. So there were things like the optpng command line tool for minifying PNG images, the JPEG optim tool for minifying JPEGs, etc. I learned all the command line options, stuff like that. And the way the code worked was someone, sent an image to the service. The service would literally shell out to these command line tools. The command line tools would then optimize the image. And then once they were done, we would take the resulting file and send it back to the developer. So this was like super basic, but it worked really well. And things actually worked this way. I actually built this service. I put it online. I wrote some documentation for it. I was a personal user of it, but I hadn't really shared it around much. But then I added it to the Rapid API marketplace. And this was like, again, a really long time ago. I think it was actually called Shape at the time. But I added it to like this API abstraction marketplace. I listed it on there. And a couple months later, I started getting VPS notifications that basically my server was under load. And when I went back to take a look at it, what I realized is the service was not really functional. And that was because there was way too many people actually using the thing. So people just started using the free APIs and it was getting somewhat popular. So what ended up happening, what ended up happening is I said, all right, I'm going to go ahead and scale this thing up. So what I did is I spun up a second VPS server and I spun up a load balancer and I said, okay, obviously the best thing you can do here is horizontally scale this. Now I'd actually built this application in a really early release of Node. And so what I did was I literally had that, the package.json file. So I spun up the new VPS. I ran an npm install, started up the web server. Everything was fine. Spun up the load balancer, put both VPS servers behind the new load balancer. And finally, I updated the DNS record. So all new incoming requests would hit the load balancer first and then either VPS server A or B. Well, here was the issue. I put it online. I tested the service once. It was working great. But I started getting a lot of emails from users saying, hey, the service is no longer working. What's the deal? And when I went to look into it, it actually took me a little bit to debug because again, it was a side project. I didn't really have proper alerting or logging or anything like this. But what I realized is that, if the load balancer happened to hit the new VPS server instead of the original, the request never worked. And the reason why is because even though I had all of my node dependencies and my web server running, I had not actually installed all of these command line tools on the new VPS server. And this is where that 12-factor app principle thing makes a lot more sense, right? So you always want to explicitly declare and isolate your dependencies. But the thing some people forget is that means all of the dependencies your application needs to run. Like in my case, it wasn't just my code, like the NPM stuff. It was also the command line binary tools I had installed. It was like all of these other things that my application relied on to work really well. And so, nowadays, I think it's a little bit easier to do this using tools like Docker or Kubernetes, where you have containers that are being operated and you have not only your code set up and your NPM packages and everything else you might be using, but also all the other dependencies that your code might be relying on, right? So that's really the idea. And yeah, that's why you always want to make sure to explicitly declare and isolate your dependencies and not do what I did. All right, next, configuration. So the 12-factor app principles basically say that when you are working with configuration data, you should store it in environment variables. Now, I think this advice is still great. There's certain situations where it's not as useful nowadays, but I think the core premise still holds true. So we're going to talk about it. So how did I screw this up? Because again, it sounds pretty simple. Well, back in the day, I did a lot of telco work. And so when I had left my first job, I basically started a tech company and we were building various telco services for 6 years or something like this. And all these services were built on top of this open source Linux software called Asterisk. So it has its own programming language and things like that, but it basically lets you do things like automate, send and receive phone calls, SMS messages, anything telco related. It's pretty fun. And at the time, we had this free teleconferencing service, and the teleconferencing service was hosted on Rackspace and was getting relatively popular. So originally, the service was actually like hosted in an actual data center, all the core parts of it, anyways. And I had started to migrate this thing to Rackspace when this story takes place. So I was in the process of migrating this thing over to Rackspace, and what I was doing at the time is I had just learned about Puppet, the configuration management software. It was still really new. And so what I was doing was writing Puppet configuration files to basically bootstrap all of my Asterisk server setup, because we were running maybe 15 or 20 Asterisk servers, and it was becoming a huge pain to manage. And so by doing this, I'd be able to save myself a lot of operations time. So as I'm working on this, I got everything working with Puppet, but the one thing I still had to do was to bootstrap the entire process through my CI server, which was Hudson at the time. And so essentially what I had to do was I had to figure out, all right, I can run Puppet on a Rackspace server and it will install all the operating system packages I need, copy over my code and do all that stuff. But I still don't exactly know how to bootstrap the server itself. Like, how do I provision new Rackspace servers when we're under load? How do I deprovision them when we're not under load? And so what I did is I looked into it, and Rackspace had an API key that you could use. There wasn't Terraform at the time, unfortunately. So I did it manually. I basically wrote some code, and what the code did was I deployed it to GitHub, but essentially I would take the Rackspace API key, I'd make API requests to Rackspace, and I'd provision a new server. I would install Puppet, then I would run Puppet and have it, pull down all of my code to bootstrap the server. Now, I set all this up. I tested it out locally. Things were working great. And this was all running in production, by the way. And then I said, okay, I'm at the point now where I can actually deploy this thing live for reals. And what it's going to do, if everything works well, is it's going to go to the CI server. It's going to use the Rackspace API key. It's going to bootstrap a brand new instance. It's going to get everything running smoothly, and hopefully we'll be good. And again, I did extensive local testing before pushing this thing live, and I was like, this works great. Here's where I screwed up, though. In order to make this work, I got lazy. I think it was like, I'm not even joking, it was literally like a Friday afternoon. I was trying to get things live before taking off for the weekend, and I thought, I'm just gonna like skip some of the lame stuff. So what I did was, even though this was a big open source project, I decided that just for a few minutes, I was going to take my Rackspace API key, check it into GitHub, instead of like doing some weird stuff where I would like, manually like put it in a file on the Hudson server or something like that. I said, I don't really have time. I'm just going to go ahead and check it straight into GitHub. And that way I'll be able to bootstrap the entire thing. So the CI server will run, clone my GitHub repo with my API key in it, run the bootstrapping commands, get everything up and running, etc. So I push this thing live, and instantly everything's working great. So within 10 minutes, I see, the new server being provisioned, everything's working. I test it out, it's great. And I thought, things actually worked pretty well. Even though I put my public API key on GitHub, like there were no indications that this was bad. So I called it a day, and I said, next week I'm going to clean all this up. It's going to be awesome, and it's going to be super smooth. And I basically logged off. Well, as soon as I did that, what happened behind the scenes was someone was like, crawling GitHub public repositories, looking for idiots like me that were checking their sensitive credentials like a Rackspace API key straight into GitHub. And what they did is they went to my GitHub repo, grabbed my API key, and immediately started provisioning massive cloud servers. So when I woke up in the morning, I see a ton of these Rackspace emails coming in. And these Rackspace emails are essentially saying, hey, you've gone past your billing limit. You need to update your credit card details, stuff like that. And I look at one of the emails, I open it up so I have the full view, and it says you're basically negative 25K on your account balance. And I was just freaking out. I was really young. I definitely did not have $25,000 just laying around. And so I completely freaked out. And so what did I do? Well, thankfully, Rackspace support, when I talked to them, completely wiped the debt and said, hey, don't worry about it. This happens all the time. Just don't do that anymore. But the thing here is that even though I knew better at the time that this was a bad idea, I thought, what are the odds this is going to happen to me? Like, I'm sure it's fine, honestly, and people probably blow this out of proportion all the time. And this was, 10 plus years ago. But the reality of the situation is, no, I think that, when you are building applications, always respect the best practices, because you are definitely not immune from the consequences if you do not. And I think that a lot of security issues are really caused by smart people that know better, but maybe just get lazy sometimes, like me. So that's my fun story about how you absolutely shouldn't do this. And if you are going to have configuration data stored securely, ideally put it in an environment variable somewhere that you can easily access, that's safe. And yeah. All right, next, let's talk about backing services. You always want to treat backing services as attached resources. So what does this mean? Well, imagine you have a production deployment. That production deployment probably isn't a standalone service, right? Like, it probably depends on things like an SMTP server, an Amazon S3 bucket, a Postgres server, et cetera. And the idea here is that when you're building these scalable web applications, you really want to make it so that it's easy for you to attach and detach these backing services whenever you need to. basically what that means is you ideally want to be able to connect to them with a single string so you can switch them out at any time without any sort of hassle. Let me get a sip of coffee here. So this picture on the left, this is actually me as a young programmer. I was super happy and my life was amazing. I was, super into programming, and I basically thought, like a lot of young programmers at the time, I was maybe 12 years old. I thought, you know what? I've learned a bit about programming. I'm having a blast. I should make a blog. And so I started custom building this blog, and I ran it for many, many years. And this thing was an amalgamation. It was hundreds of .php files sitting in var dub on a shared web host. And the entire thing was running off of the local MySQL database server, running off 127.0.0.1 with no credentials, of course. And I happily worked on this blog for many, many years. Now, I started this when I was maybe, like, let's say 13 or 14 years old, something like this. And I added features to it. I added all sorts of other random games and things that I built onto this shared web host. And when I went to university, I said, you know what? What's a way for me to make friends at school and, break the awkwardness? And I thought, I have an idea. Maybe I should just give out pirated movies to everyone. And at the time, Netflix had the DVD mail-in service where you could subscribe to get a certain amount of DVDs shipped to your house. And so what I did is my roommates and I subscribed to that, where we would get 4 DVDs a week. And we would basically request all the new popular movies. We would get them in. We would start ripping them. And then I would upload them. By the way, we ripped them using this Perl program called DVD::rip. Oh, amazing program back in the day. So we would get the files, we'd upload them onto my shared web host, and then I would basically like pass this hidden link around to everyone I met at school, and they could just go on there and just download stuff directly from my shared web host. So people were like ecstatic internally at the school. And this worked really well. By the way, if you are looking for ways to make friends, I highly recommend this. Maybe not the most ethical thing to do, but it will certainly get you friends. So did that. But one day I ran into this issue where doing one of our weekly batches of uploads, I started running out of disk space on my shared web host. And so I thought, okay, I've been running this blog for, what is it, like 7 years at this point. It's time for me to start to architect this thing like a real application. And by this point in time, I knew a lot more of the best practices and things. I knew that all of my code was junk, and I thought, all right, this is a good opportunity to start cleaning things up. So what I did was, the first thing I did is actually provisioned a brand new MySQL server, like a proper one, not like the free, built into localhost MySQL server on these, shared web hosts. This is like a proper MySQL database. So I provisioned one of these bad boys. I thought, all right, first thing I'm going to do is copy the database over. So I copied everything over from my old web server from my old MySQL server into the new one, got everything there. And I thought, all right, I'm just going to go in, update my code real quick to start using the new database. And then bam, everything will be good. I can get rid of this. And then I'll start, I'll create a file server and things like that. Well, here's the problem I ran into. When I actually went to update my code to talk to the new MySQL database, I realized that this was actually going to be a huge pain in the ass. And the reason why is because the MySQL database that I was using for all these years, of course, was on localhost. It assumed that there was no credentials to access it. And I also had literally hundreds of PHP files where I was literally just, calling, connect to MySQL in PHP and just passing no parameters in. And so I had like no easy way of going through these hundreds of files and changing them to use this new external IP database with like, actual passwords and usernames and things like that. It was a huge pain. And so it actually took me a few days worth of work to go through all my junky old code and completely rewrite huge swaths of it to rely on proper stuff. And when I did that, one of the things I did is I sort of made things really nice. Like I took the new MySQL database connection string, I put it into a proper like configuration file where all that stuff was stored. And then from that point forward, I knew, oh, in the future, if I need to upgrade my database server or do something new there, I can literally just swap this one string out and then everything will work nicely. So that's how the 12-factor app sort of bit me in the butt. And hopefully you will not make that same mistake. And by the way, the wolves are because at the time, when I realized how much work I had to do, I was just like fuming. So yeah. All right, 5th factor, build, release, and run. So you always want to strictly separate the build and run stages of your application. So let's say you have a project, you have some code. Usually you're going to have some sort of build code, or some sort of build step, which is going to build things. And that build step is going to have some configuration data that goes along with it. And when you combine that configuration data into your build process, you should ideally be able to create a release artifact. Now, also, Kyle just commented, he said, inside of you, there are 2 wolves. So true. So poetic. Shout out to Kyle. But yeah, so the 12-factor app says you basically ideally want to have the build stage separate from your code, which is separate from your configuration data. And all those things should be used to generate a release artifact. The release artifact is what you can use to deploy things live, but having these things separate makes maintaining and building the applications a lot easier. So let's talk about this. Well, back again when I was a young programmer, living at my parents' house, working, in my bedroom late at night on this old DOS computer, I was a total script kiddie, and I had like zero best practice knowledge at all. I didn't know anything about version control. It was terrible. And so what I did is I was working on that personal website, that blog I told you about earlier, and I had this folder on my desktop which had the website code in it. And I had this shared web host, which again I was deploying things to. And the way I would deploy code is I would write some code locally, then I would SCP all the code over onto the shared web host server, and then I would go to the website, refresh the page, and bam, things would run. Well, this worked okay for a while, but what happened is after time, I would get lazy because the more this project grew, the slower this SCP command became, until eventually I said, I don't want to wait like 5 minutes between every change to like upload things here. Why don't I just SSH straight into the web server, do the coding there, and get things working quicker? And so I did that. And what I would do then is I would say, all right, well, I'm in here, I got this code working. So now I'm going to take the working code and I'm going to copy it back into my desktop version, like at home, which is like my backup basically, to make sure that that version of the code base was up to date too. But then sometimes I would then like change code here again. And so I'd like copy it back over and like try to figure out like, oh, what did I do last time? I was basically being my own version of Git in my head, and it was an absolute disaster. And this was incredibly difficult to work on, and actually have these like PTSD dreams every now and again about thinking back to this project and how much a ridiculous amount of time I spent working on this. And I think to myself, it would have been so great had I known about things like what is a build stage and where should you keep your configuration data and why is it good to keep it separate and how do you actually deploy things? Well, you create a release artifact and then you copy that somewhere, right? But all of these things would have made my life so much easier had I known them. And so going back to the 12-factor application principles, it's always good to separate those stages of your build out so that you don't run into headaches, like sort of what I did when I was a little kid. All right, so next up, let's talk about processes. So the 12-factor app says you should always execute your app as a collection of one or more stateless processes. Now, the key word here is stateless. So when I was building that free conference calling app at that company years ago, we had this free conference calling application, like I said, and it was running in a data center, at least initially. And the way this worked is we had these multiple servers running the application. They were all running Asterisk behind the scenes. And one of the really cool features about this free conference calling app is, let's say you're a company and you wanted to run conference calls. Well, what you would do is you would go to our website, you would get a dedicated conference calling phone number for free. And then we would basically allow you to, we would basically pair it up and say, okay, these blocks of phone numbers go to this server, these blocks of phone numbers go to this server, etc. And the reason people liked our service is because they could actually call into the service or use the website. They could custom record their own audio prompts for literally every part of the system. And then when people called into the conference line, they would hear like their custom recordings for everything. And so that was like a cool distinguishing feature that we had at the time. Well, the way I architected this is on the back end, when we would allow people to store these custom MP3s, they would go directly onto the conference calling server that the person's phone numbers were bound to. And so that was just the most efficient thing we could do at the time. Well, this worked pretty great until one day we had some issues, and one of our conference calling servers at a data center actually went completely offline. This was a server like way out in the middle of nowhere in Lufkin, Texas, if you know where that is. It's a tiny little city in, northeast-ish Texas. Super, super small place. But I had to hop on a plane and fly out there and literally get this 1U rack server running again. But essentially what I realized is that this was a problem because when the server went down, the entire thing was gone. And what I realized is when the server went down, what I did was I took all the numbers that were routed to server A, and I said, okay, we're going to take these, and since the service is down, we're going to migrate people to another server, migrated them to server B, and I started getting user complaints because even though the conference calling lines went back up, none of the custom audio prompts were there. And that's because, again, all these custom audio prompts are stored on these servers, and when the server goes down, the audio prompts were lost. Unfortunately, I was actually never able to recover this because there was like a pretty bad hardware failure, and so it wasn't able to get it back, and that pissed off a lot of people. But I learned since then that when you're deploying your application, it really needs to be truly stateless. And in my case, this application, this web application was not stateless because it's running on the server. The server has a bunch of music files it relies on, and those files aren't packaged with the application, and there's no way for them to be retrieved. And so it's not actually stateless. So going back to the 12-factor app principles, just make sure that when you're deploying your application, it's a set of stateless processes and not ones that are stateful, like in my case. All right, the next factor is all about port binding. This was actually not that interesting nowadays, I don't think, because people rarely deploy web applications directly on a server where you are like manually setting a port. But I'll quickly go through it. The idea is back in the day when you're building a web service, you would always, bind your HTTP server directly to port 80 if you wanted an unencrypted site. Terrible idea. Or maybe port 443 if you were using, SSL, I guess, or TLS, or sorry, SSL back then, TLS now. If you wanted a secure site. But basically what the 12-factor app says is don't do that. Like let the routing infrastructure of your application handle all the port binding stuff. That way your application can be deployed in any environment and it'll be totally fine. And so basically deploy your application to a variable port number and let the routing infrastructure set all of that stuff up for you. So nothing crazy there. Next, let's talk about concurrency. So when you're building scalable web applications, you want to be able to scale your application out via the process model. So what does this mean? Well, let's say you have a web server, right? And you have one web server running, one web process rather. Ideally, if you want to support more capacity and more throughput, you should be able to spin up another instance of this web process. It should be ephemeral. And that way you can scale it down, you can scale it up, you can add as many of these things as you want horizontally to support more capacity. Same thing with other types of processes. So maybe you have some background worker processes you want to scale up and down, or a clock process. There's all sorts of things people want to do. And the idea is you want these things to be ephemeral, you want to be stateless, and you want to be able to spin them up and down on demand. Now, the way I screwed this up was another project from when I was a kid. So one of the first real big applications I ever built was something I was really excited about at the time. It was like an IRC web application. And so when I got into programming, like IRC is where I made a ton of friends and learned a ton of stuff. And at the time I was using like XChat, and I was really into the idea of having like a more visual version of IRC. So anyone on the web could sign in. And at the time, this was like quite a while ago, there wasn't a good application or a good web application to help you do that. And so I thought, I'm going to build this thing out. It's going to be huge. People are going to love it. And I started working on this. And by the way, at the time I was writing this entire thing in like raw C code. And so this was like definitely not an ideal web project at all. But I built this thing out and I wanted to architect it to scale. And so I decided to build the entire thing as a Linux system daemon. And so basically the way it would work is there's this massive system daemon running. So when the server booted up, it would basically spawn or it would use fork basically and fork off a bunch of these sub processes every time a user in the web application joined a chat room. And each of those things would have their own IRC connection and manage like, all the TCP connections and things like this. And I thought this was brilliant. I was like, this is going to scale so well. But I basically knew nothing about, things like inter-process communication and how to handle seg faults in really complex environments, and how to handle cascading failures and things like that. And so when the service started to get a little bit popular and I had, 10 friends or something like that using it, what basically happened is, bad luck, right? So maybe something would happen and the IRC server would split or some exception was unhandled. And one of these child processes will get killed. And when that happened, it would oftentimes cause cascading failures where the main system daemon would then, exit it would be restarted by the operating system, but that would then disconnect everyone on the server from all of their IRC chats. And so it was like a huge problem. And as much as I would love to tell you that I fixed this and re-architected it and made everything awesome, I spent tons of time on this. I was never able to get around this like underlying issue about how do I do proper IPC? How do I avoid these things? How do I properly architect it so this just doesn't happen? And so this project actually got completely killed off because I didn't adhere to the 12-factor principle here. And the principle that I should have followed was keeping my application stateless and ephemeral. So instead of having like one big massive stateful application that does everything, I should have had a bunch of small lightweight processes I could just add and remove and scale up and down as I needed. And that way I wouldn't be in situations where I'm dealing with all this complicated stuff. Instead, leave that to your routing layer, but at the time I did not know that. So hence the issues. All right, next, disposability. So the idea here is you want to maximize the robustness of your application by having really fast startup times. So if you're booting a web app, it should start up really quick, and fast, graceful shutdowns. So ideally what this means is if your application receives a SIG term, you should shut down gracefully. You should shut down within a couple seconds. Don't like run massive database commands and queries and things like that that are going to take a while when you're exiting a process. And also you want to be robust against sudden death. So let's say you're in the middle of, running this expensive queue, process, and you get a SIG term. You should shut down, and you should do it in such a way that when you start up again, or when another process, starts up, that task should not be lost forever. It should still be handled properly. So you basically just want to be robust. So how did I screw this up? Well, that conference calling application I told you about earlier was a great example of this, because it was a really popular production application with like hundreds of thousands of users in North America. And I had scaled it from, originally being in data center to being in multiple data centers, that being in multiple data centers and being in the cloud partially in this hybrid environment. And so I'd grown it from nothing. And so there was all sorts of interesting scaling issues I ran into. And one of them was that at one point, I'd gotten the entire thing up and running in Rackspace to the point where we were able to add additional cloud resources when demand was high and then turn them off when demand was low. And when I wrote my first auto scaling software, it was all custom Python code at the time. Essentially, the way it worked is like this. So requests would come into our load balancer. They'd be routed to these various, asterisk processes that we're running. And there was always a baseline number of processes running. And what would happen is the autoscaler would say, hey, there's a lot of calls coming in. We're actually going to go ahead and spin up some additional processes to support the load. But what I realized is the very first time I ran this, when the autoscaler would spin up new processes, they'd spin up. It'd take about 30 seconds or so. Nothing would happen. And then they would just restart. And then they would try to start again and then restart. And they never really came online. And so I thought there was an issue with the autoscaler, and I spent all this time debugging it before I finally realized the issue wasn't with the autoscaler. It was actually a much more rudimentary issue. So this is like pseudocode, but this is very similar to what the actual production code looked like at the time. In my startup function for the web server, I would essentially say download audio, which is where I would download the audio files for the custom conference lines that power this process. So we'd be able to, serve them. And then once I was done, I would then bind myself to the appropriate port that the load balancer had assigned me so that I would be able to start accepting incoming web requests and start processing calls. Now, all this stuff makes a lot of sense, right? The issue though, and this is what took me a long time to figure out, is that this was actually the problem. And the problem was that because previously I told you I had that incident where I lost all those custom audio recordings because they were bound to a server. Well, after that happened, I'd actually migrated everything into a massive file server on Rackspace. It was like a big NFS box. And so this download audio function would literally connect to that NFS server and download like tens of gigabytes worth of audio files from a Rackspace server on the public internet. And the reason my load balancer viewed these processes as never working and binding to a port was because this function took a lot more than 30 seconds to run. And so my autoscaler would say, hey, we're going to start the web server. And if we notice it doesn't bind to the port within 30 seconds, there must have been an issue with it. And so it kills the process and restarts it, right? And so going back to that 12-factor app principle here, you really want to make sure that your application starts quickly, that it shuts down quickly, that it shuts down cleanly. All of those things, they're really important, especially in real world applications, because things like this can really bite you in the butt and cause you massive amounts of headaches. So after this, I think learned my lesson that, it is really valuable to build these things to be fast and, not fragile, basically, and totally worth the extra time and effort that goes into it. All right, so next, let's talk about dev prod parity. The idea here is really simple. It's that you should always keep your development, staging, and production environments as similar as humanly possible. Sounds simple, right? So what this means, you have some code. Actually, one sec. So good. So, what are the ways you can screw this up, right? Well, basically the idea is, and by the way, I am extremely guilty of committing this sin, even to this very day, even though I know it's so wrong, I still do it all the time and I feel horribly guilty about it. But basically what happens is you have some code and you're working on it. And maybe your code is deployed in production using like a Postgres database, which is awesome. Well, what I do a lot of the time is when I'm doing local development, instead of installing Postgres and having a server run, I'll use something like SQLite, because SQLite doesn't require a server. It will just go ahead and automatically create a text file on your development box. That way it keeps it a little more lightweight. It has the same API. So like everything just works out of the box. It's just you're using SQLite instead of Postgres. And in this scenario, obviously, like it's not good because you have one type of database locally and another type of database in production. And that means you're at risk for something breaking, right? Like maybe you do some testing locally on SQLite and things don't work in Postgres when you deploy, and that's not good. Well, this has happened to me multiple times, but I will use SQLite, work on something, and then deploy to production and just see a bunch of varchar issues. So one example of this is in a real production application, like, I would literally do this all the time. Like, I was building Django apps a lot back then. And so I define some constraints and say, hey, this is a text field that has a limit of like 15 characters. Then when I, actually deploy the schema to Postgres, like it has an actual limit, but SQLite completely ignores any constraints on a text field. And so it will completely ignore that 15 character limit, which means when I'm doing development locally, like things will be working just fine. And then I deploy to production and bam, shit's broken. So it's pretty terrible. Also, Micah, our announcer, just dropped a comment and said, is this a confessional? Because I use the H2 in-memory database locally all the time, ... Micah, that's bad, man. I'm just joking. But yeah, like I think one of the funny things about this one in particular is even as experienced developers, a lot of us know these things, but we just ignore them anyway sometimes. And that's when you have problems, when you know better, but you just make silly little mistakes or you forget to do things here and there. So even really experienced programmers have been doing this with job for 20 plus years, right? We'll still run into these issues. And that's part of the reason why I think it's so interesting. All right, next, we're almost at the end, everyone. We have logs. So the idea here is you want to treat your logs as event streams. So what does this mean? Well, you have an application and your application is going to generate logs, right? And there's a couple of rules. So first of all, you always want your logs ordered by timestamp, which makes sense. You always want to write them to standard out. So if you have a web app, for example, you want to just dump your logs straight to the console. And your log should consist of two things. Not only your process, like your web application process logs, but also all of the logs of your backing services. So you should have one big logging database. You should be able to filter it so you can see where they're coming from, obviously, but it should consist of like your database logs, your web server logs, your background worker logs, etc. And if you don't do this, you can run into problems. Now, in my particular case, the story I'm about to tell you actually cost the company I was at, the one I was running at the time, almost $500,000 US. So pretty big deal. So here's how it went down. Again, going back to that conference calling service I told you about before, we had that conference calling service running. And the way this worked is there's a web application built in Django, and there's an API service also built in Django. Then there was a bunch of these like Astra servers that were running on physical hardware in actual data centers. And what would happen is the way we made money from this service is we partnered with these rural telecom providers, like out in places like Lufkin, Texas, Copley, Pennsylvania, like all Mattoon, Illinois, like all these really random small cities, right? Because they were incentivized. So the more people called in to these remote locations, the government would subsidize those calls. And, at the time, let's say these telecom providers would get about $1 per minute from the government. And we would basically run free teleconferencing services in these data centers. And we would just split that subsidy money with the provider. So we would, do all the work of like setting up these servers and building a service and doing everything. And we would just split the subsidy money with these providers. The only downside was these are rural telecoms and they don't really have like a lot of technical expertise on staff or anything like that. And so billing became really tricky. And the only way we were able to actually get paid and prove that like we generated a certain amount of traffic for the telecoms was essentially by like logging billable calls and then giving this report to the phone company at the end of the month. And so what would happen is people would, call in and use the free services. They would generate API requests to the API server, and that server would just literally like dump all of the call logs into like a huge calls.csv file. And what I would do at the end of the month is I would literally just copy this calls.csv file straight from the Rackspace server it was running on to my local desktop. Then I would do some analysis on it, and then I would email it to the telco provider like in a zip file. So it was super basic. And that's how we got paid. And this was like hundreds of thousands of dollars, like I said. So 1 month, it's about, around halfway through the month, let's say. And I was running a report for one of my partners, and we were basically saying, okay, where are we at so far in the month? How many minutes have we used? Like, what is our revenue estimates looking like, basically? And I ran the command, and I WC-L the file to see how many calls there are, and I started running some commands to calculate the totals up. And what I realized is when I ran my Python scripts, the total amount of billable minutes that we had was the exact same as the previous time I ran the command a couple weeks ago. And I was like, that is super weird. Like, why is this the exact same as before? Like, that doesn't make any sense unless we somehow got insanely lucky. And right now, halfway through the month, we're at the total amount that we had the prior month. It would just, the odds of that were astronomically small. And so I thought about it and I looked, and then I slowly started to like freak out. And the reason I freaked out is because, basically what I'd done is I'd switched this SCP arguments around. So instead of me copying the calls.csv file from the remote server onto my localhost, I'd actually copied the old calls.csv file from 2 weeks ago from my local computer onto the remote server, overriding the log file that was there, which is like a massive epic screw up, and so I started freaking out. And the reason I freaked out is because when I was going through the process of building and architecting the system, I specifically disabled logging on all of these servers. Now, the reason I did that is because we have a lot of calls coming in, and these Astra servers used to be generating lots of log files, and these were in these rural areas. And every now and again, the server would literally fill up with logs and just stop functioning. And so I would fly out there and fix it. But I hadn't actually gotten around to writing any sort of code to like limit the log file sizes or doing anything like that. And so I said, I'm just going to disable it because like everything's really logged up here anyways. And like, that's the main thing we care about. So when I did this and I realized what I had done, I freaked out and I spent a ridiculous amount of time trying to find some logs that I could track down so I could reconstruct this entire thing. And unfortunately, I was unable to. And so this was literally like a massive, massive amount of money we completely lost due to this screw up. Now, thankfully, it was a company I was like a part owner of. And so like I was not immediately fired. But, stuff like this is like a huge deal. And like you can really make like terrible business altering decisions so quickly with some of these little mistakes. Now, what should you do in situations like this? Well, what you should do is use a log router. It could be something like, Sumo Logic or Loggly or Papertrail or LogDNA or like your own custom stuff, right? Like any sort of place, but you should have logs from each of these services and they should all be aggregated somewhere so that you can actually reconstruct things. You can figure things out, even in circumstances where the worst possible scenario happens. So that's a lesson about logging. Next, the final best practice is all about admin processes. So the 12-factor app states that you always want to run your admin and management tasks as one-off processes. So what does this mean? Well, let's say you want to run a database migration, right? Maybe you would, in Django, you would say Python manage.py migrate, and this would, run your database migration code. Now, if you need to do this on a production server, ideally what you should do is you should codify this. So you should write some code that will like run the database migration code. You should put it in your code base. You should deploy it to your production infrastructure, and then you should trigger it to run on your production infrastructure. That way you can have like testing and like continuous, integration and deployment, all of these things, but you'll have confidence when you run it that things are going to work is the main part, the main point. So you always want to run these things as one-off processes in your production infrastructure. So what did I screw up? Well, this is actually exactly what I screwed up, a database migration. So this was, again, going back to that conference calling application at the time. It was like a weekend and I was trying to finish this stuff. It was like a new feature we were getting out the door. I was working on it with my partner like for weeks, and I was completely burned out at this point. And the new feature added some new database columns. And so what I needed to do when I deployed it, like everything was working locally just fine. And I was literally just getting this thing deployed. And so what I did was I had the feature needed to alter a table, and I needed some database migration code to do that. And I thought to myself, all right, now I could go ahead and do what I just described before, which is the right way to do it. Like I could like write some code, have like a management task, so I could run Python, manage.py, custom migrate or whatever I need to do. I could deploy that into my production instance. I could schedule a task to run there in like 10 minutes or whatever to, once it was through CI and CD and all that stuff, to actually trigger the task and run it in our normal production environment. But I basically said to myself, well, I only need to do it once, and it would save me like a couple hours of like waiting and testing and things like that. So I'm just going to go ahead and run the migration on my laptop. Now, I thought this was going to be totally fine because I tested it locally so much. So I ran the migration. Everything worked. I got literally 0 errors. It said successfully migrated, right? And I deploy the feature and I push it into production. I wait for it to go through CI and CD and stuff. And I'm like, all right, cool. Looks like we're good. I'm out of here. So as soon as I push it live, I peace out. Well, right after that, I get angry calls from my partner. And he's like, hey, I know you've been working a lot, but like the entire site is down. And I was like, oh, of course. Like what happens, So after doing some debugging, I realized that in my tired state, when I ran this migration command, I had forgotten to update the environment variables to point to production. And so I was literally just doing a migration against my local SQLite database. And of course, the new feature was relying on like database columns that like didn't exist. And so it was just airing out massively and crashing everything in production. So that is my story. So yeah, don't do that. Even when you do need to run these sort of like one-off tasks, these management tasks, like put them into the proper infrastructure, trigger them, put them in your code, do testing and things like that. Don't be a lazy bum. And that's it. I can't believe it. We actually worked through all 12 of the 12-factor app principles. In case you're interested in this, by the way, you should absolutely go check out it's 12factor.net. This is the actual manifesto, which contains these 12-factor app principles. It's super cool. And yeah, thank you so much. So if you want to learn some more stuff like this, I do some writing on my personal site. It's rdeggs.com. You should definitely follow Snyk on Twitter. We're SnykSec. And snyk.io is our website. So check it out. And with that, I'm going to bring Micah back on the stream. Hello, Micah.
Hello. Good to be back.
Thank you. So what did you think? Terrible? Embarrassing? Have you done worse?
Yes. So terrible. No, it was great. It was great. I love going through all this, and there's nothing more cathartic than admitting the mistakes that you've made in the past. I dropped a little something in chat where I once ran a test suite against production by accident. And as most test suites do, if you have functional tests, they go and drop the database and add all kinds of, test data in there. And I toasted my production database. It was a while ago. I haven't done anything that embarrassing or scary since. Fortunately, we had a backup, and now it may be a sign of age, but I really enjoy not having access to production in most cases. I'm happy to leave that to some other team.
Well, I thank you for sharing your story, and I feel a little bit less terrible. I'm also ashamed to admit that, when I was making this talk, I specifically included a lot of stories from when I was younger. You might have mentioned, or you might have noticed. That's because I still do a lot of these things, but it's much more embarrassing nowadays because I've been programming for so long. So like, got to keep those ones pretty far in the past to feel a little bit comfortable sharing in a public forum. But
Indeed.
yeah. Any advice for people that are watching this who are new to development, new to security? Like, you have any advice for them to try to avoid these things?
Yeah, well, as a developer, embrace security early, and you may avoid some of these things. It's for me, security has always been a part of my development practice because, in my misspent youth, I was kind of a hacking around and was always interested in security, but that's not the case for all developers. But developers should all take on some aspect of security in their program, even if it's to use tools to help them write secure code so that they don't get jammed up further down the road. So that's my advice. Think about security and operations early and often. Like, even if you don't have access to production, like I don't anymore, for the benefit of everybody, it's still worthwhile to know how to work with a CI/CD pipeline and the kind of you were talking about Puppet earlier, like the kinds of things that operations people kind of live in every day. It's good for developers to have a passing knowledge of that stuff too.
And I would just also add, like, I have screwed up so many production applications in my life. Like, I'm not exaggerating, it's a lot. And I've made terrible mistakes. But one thing I feel confident in saying is, like, pretty much everyone's going to make mistakes, right? Like, no one's perfect. Even like amazing developers that I work with today who are absolutely incredible, like Micah, we still screw things up literally all the time. And maybe it's not as public, maybe it's not as bad, but don't let that discourage you. Like, treat them as learning experiences. You just keep getting better and better, and like, don't let it stress you out. It's not the end of your life, so hang in there is what I'm trying to say.
Yeah, it's good advice.
Cool.
Get back up and dust yourself off.
Totally. Well, I realize it's sort of the end of the session here. So everyone, thank you so much for coming to the first Bay Area DevSecCon meetup. It means a lot to me. Micah, thank you so much for helping us intro and kick this thing off. When the aliens find this recording 10,000 years in the future from now, you're going to be famous. So thank you.
I suspect that's how long it'll take for me to become famous. I'm okay with that. I don't need fame.
Awesome. Well, thanks again. And thanks everyone who's watching from home. Again, we are going to have an in-person one of these next month. So I will send out the details once I officially lock in the venue, but it's looking like it's going to be in South Bay. So hopefully you'll be able to make it. And please join our Discord server if you haven't already, so you can like leave some ideas, suggestions. If you have any requests for like food or drinks or other cool things you might want to do, or if you want to give a talk next time, that'd be amazing. So hit me up, and looking forward to seeing you all at the next one of these things. So thanks. Bye, everyone.
Good one, everybody.